and welcome to the third and final part of exercise session 5. We're now going to have a look at systems of equations. So basically, in this case, we're looking to find where multiple equations, so a set of equations is going to give us 1, 0 solutions or multiple solutions. And a way you can think about this is, for this, I'd like to draw your attention to question A of 6. It is 10x plus 5y is equal to 5, and 2x is equal to minus 8y is equal to 10. Okay, for this, just try to follow. Try to listen to me. Do not start calculating anything yet, because I will show you shortly. It's not really necessary to do it this way, but I just want to show you something. So this is also, let's rewrite it a little bit, and here you get it. So y is equal to 1 minus 2x, right? That's the one way you could rewrite it, or in this case, downstairs, it's going to be y is equal to 10 over minus 8 minus, no, not minus 2x, plus 2x. So you see, these are actually two straight lines. They are just linear equations. And actually, when you're trying to solve a system of equations like this, we can quickly draw these functions. So more or less, the first one is going to have a directional coefficient of minus 2. It's going to, if it's 0, it's going to be 1. So it's going to go more or less like this. And then the other one has a positive 1, and it's at 10 over 8, so a little bit more than over here. It's going to move up. It's going to go more or less like this. Of course, these are by no means perfect drawings. So this is going to be 10 over, sorry, this is wrong. It's not here. It should be at the bottom. It should be like this. So this is 10 minus 10 over 8 plus 2x, and this is 1 minus 2x. Actually, what we're trying to find is, when we try to solve this kind of linear set of equations or systems of equations, it doesn't necessarily need to be linear, system of equations, we're trying to find where these two cross. Because at this point where they cross, they're going to be equal at each other at exactly the same time. So this is what we're trying to solve. And it's good to keep that in the back of your mind, especially when things get more complicated. Actually, you're just trying to find where these lines cross. Okay, that being said, let's try and solve this. And for this, I've mentioned in the exercise, we're interested in doing it with either the substitution or the addition method. And the substitution and addition method are both perfectly fine and perfectly possible to use. In general, I prefer the addition method because, well, it's much easier to keep track of things when you're doing very complicated sets of equations, but the substitution method is also very, very useful. So that being said, I'm going to solve the first string to an addition method. What does the addition method mean? It basically means you're going to take one row, so this is a row, one of them, this is the second row, and you're going to try and use that one to eliminate something in another row. So it doesn't matter which row you take. You can take the first one and use it to eliminate something in the second one, or you can take the second one to eliminate something in the first one. But in this case, when you look at it, you say, well, I think this is the easiest thing to eliminate something. This 10x and this 2x, they look very neatly the same. You can say row 1 minus 5 times row 2. So you're going to do that, and that's why it's called the addition method. You basically add rows together, or you subtract them with some kind of constant over here. If you do that, the row you use to manipulate things with, just leave it as it is. So 2x minus 8y is equal to 10. And now we have to calculate this. So 2x times minus 5 is going to give us minus 10x. We add them together. Okay, great. It's going to give us 0x. Okay, minus 5, so it's going to give us, okay, it's going to give us 40, so it's going to give us 45y, so plus 45y. So minus 5 times minus 8y is going to give us 40y, and here we already had 5y. And that's equal to 5 minus 50, or negative 45. And now all we need to do is, well, read off our answer, because we managed to eliminate x out of our equation of the first one. And we can immediately say from this that y is equal to -1. And then over here, well, if we know that y is equal to -1, we can fill it in. So we get here 8. And so we need to find something that we need to add to, where we can add 8 to and give 10. So it's going to be x is 1. So that for the first question. Now let's go to the second question, B. And this one I'm going to solve with substitution, because, well, it's very neatly given in such a way that substitution is very easy to do. You could have already done substitution over here. You will see shortly if you don't know what I mean. And y is equal to 3 plus 2x. So the idea is really that you always try to eliminate one of the variables out of these two variable equations, right? And in this case, well, we already have some kind of expression for y given with x. So that means that we can fill that in. We could say, well, y is y, obviously, but y is also 3 plus 2x. So we fill this thing in over there. And then you do minus 2x is equal to 1. And then you don't change anything the way that, you don't change the thing that you used to substitute with. You just leave it like that. And what do you find over here? You find that 3 needs to be equal to 1. And y is equal to 3 plus 2x. And this is obviously never true. Meaning there is no solution to this exercise, to this set of equations. So where here there was one solution, here there are no solutions. And how can that be? Well, think about it when I gave you this explanation. Doesn't this minus 2x and 2x look very similar? Well, they should, because these are parallel lines. They will never cross. So this point simply cannot exist. Okay, so that's for B. Then I'm going to recommend that you make the following at home. I'm going to put a couple more. I'm going to solve 2 more, but I'm already give you the recommended for home. So C, E, and G. This one. And then let's try to make question number D together. Okay, so this already looks like a much bigger one. And for these ones, you'll see substitution is definitely possible as well, but gets very messy very quickly. So you get minus x plus 2y plus z is equal to 2, 2x plus y minus z is equal to 3, and then minus x plus y plus z is equal to 1. Okay, when you look at this, and I'm going to solve it through the addition method because I think it's much better when you're dealing with these big ones, is the first question you should ask yourself is like, what seems like an easy one to eliminate? Okay, well, you could eliminate x, so then you would have to add 2 times the first one to this one, and just subtract the first row from the third row. Possible. Also, y is possible, but here when we look at z, and you don't have to do it, it's just the easiest one. You don't actually need to multiply anything because it's just, well, there is no factor in front of any of the z's. So you could just say, well, I'm just going to add these things. So row 2 to row 1 and row 2 to row 3. Let me write that down once. So we're going to do row 1 plus row 2. And we're going to do row 3 plus row 2. We don't need to do any complicated calculations. So in this case, what are we trying to do is eliminate z from our system of equations in all the equations except one. Okay, let's see what that gives us. So we can start with writing row 2 because we use that one to perform the operation with, so we can't touch that one anymore for now. So 2x plus y minus c is equal to 3. So that one we have to leave alone for now. And then what we can do to this? Okay, so we said we added row 2 to it. So minus x plus 2x, it's just going to give us x. Okay, great. Then our y, we're going to add y to 2y, is going to give us plus 3y. Adding 3 to 2 is going to give us 5. Okay, successfully eliminated z from this equation. Okay, then let's do the same for our third row. We're going to add 2x to minus x, and we're going to get, again, x. We're going to add y to y over here, so we're going to get plus 2y. And that is going to be equal to 4. Just a second, my computer is busy. So that's going to be equal to 4. Okay, great, but there we're not really at a solution yet. Now we have a system of equation that looks more simple, but we haven't solved it yet. Okay, let's try and eliminate something else. And yeah, we can try and eliminate y. We could use the one we haven't, well, row 1 or row 3, we can use one of those to eliminate it in the other one. Well, row 2 is not going to help because, well, if you use that one, it's just going to reintroduce z in the other one. So let's have a look at this. But then x and x, they look the easiest. So what we could do is row 1 minus row 3. Or you could do row 3 minus row 1. That would also work. And in this case, we eliminate x. Okay, we rewrite the system of equations. We used the third row to manipulate, so let's leave that alone. The second one we're also going to leave for what it is, because that one didn't really help us. And then now we get at the first one, so we'll get x minus x, so 0x, great. We succeeded. And then here we're going to find y minus 3y minus 2y is just going to be y plus y, and then here 5 minus 4 is equal to 1. Okay, great. So now we can start really solving it because we have found that y is equal to 1. Then we find that if we fill it in over here, y, we find that x is equal to 2. And then we can fill in x and y over here. So we find 4 plus 1 is 5, minus z needs to be 3, so z is 2. Or in other words, we can rewrite our solution as, and we always start with x, then y, and then z, we write 2, 1, 2. And we have solved our system of equations. You could have done this with the substitution method as well, but most of the time it's more cumbersome, but not always. Okay, that being said, let's move on to question number F, the last one of this set we're gonna make together. And what do we have over there? We have minus 5x plus 2y plus z is equal to minus 9. 4x plus y is equal to minus 6z, and that's equal to 2. And then minus 4x plus 3y minus 2z is equal to negative 10. Okay, and again, let's try and solve this with the addition method. Okay, let's have a look at this and what's going to be the easiest one to solve. Okay, let's remove this because that 3 was really atrocious. It was really hard to read. Okay, so looking at this z, then, well, if you want to eliminate it, either you're going to have to work with 1 over 6 or you're going to have to do something times 6, and so you end up with very big numbers, so maybe that's not that nice. So let's not try and eliminate z just yet. Same with x, because then here, especially if you want to eliminate that 5, there's not really well, you have to work all the way up to 20 before, so you're going to have to do this times 4, this times 5. Oh, it's a whole mess. But this one looks okay, because here we just have a single y by itself, so we could just subtract the second row twice from the first row, and from the third row 3 times. And that's the easiest way to eliminate something. So here we start by eliminating y. So you see there is not really an order that's important. Okay. Oh, sorry, it's not row 3, it's row 2. So row 2, we keep it as it is. 4x plus y minus 6z is equal to 2. And then let's subtract it from the other. So here you get 4x, we have to do it times 2. So 8x, so minus 5x minus 8x is going to end up with minus 13x. Okay, y's are going to cancel each other out. Great. And then here, z plus 12z is going to give us plus 13z. And all of that is equal to minus 9 minus 4, so minus 13. Okay, same thing for our third equation, minus 4x. So we'll add this 3 times to it, and then we end up with minus 12, so minus 16x. And then we get to y, and yeah, y cleanly gets eliminated, and then we get here at minus 2z, minus, so minus 2z, and then we get here plus 18z, so that's going to give us 16z, and that's equal to negative 16. Okay, this is interesting, because if we pay close attention to this, we see that this line and this line are actually going to be the same, right? What do I mean with being the same? Well, let's simplify both of them. Let's divide them by, here let's divide this by minus 13, and then let's divide this by minus 16. So row 1 divided by minus 13, and row 3 divided by minus 16. We end up with x minus z is equal to 1. This 4x plus y minus 6z is equal to 2, and this is going to be x minus z is equal to 1. So actually I cheated. When I gave you this set of equations, and normally with 3 variables you need 3 equations to be able to find one solution. Well, I actually only gave you two distinctly different ones. I gave you x minus z is equal to 1, then 4x plus y is equal to minus 6z is equal to 2. Okay, so what does this mean? Well, that means that we cannot boil down to one solution, but there are many solutions. And this thing, what I'm talking about right now, this is really what you're going to see in Mathematics 2. Mathematics 2, we're going to talk about linear algebra, and really it's the study of all of these kind of things. But for now, what does this mean, and how can you interpret it? Well, 3 equations, these are actually planes, right? With 3 different directions. So instead of being in 2D, we're living in 3D now with x, y, and z. Well, we have some kind of plane, and we have, I'll draw it like this, and we have another kind of plane, let me give a different color, that goes maybe like this. And these two, they intersect, and they intersect not at a single point, but at an entire line. So you're going to find some kind of equation for a line. Okay, so how to find that thing? Well, the thing you have to say is, okay, I'm not going to find one solution for this, but I can express my solution in maybe one variable. And that's true, that you can do. You can express everything in one variable. Let's assume that we're going to express every coordinate we find with z. So we're going to say our z coordinate is just going to be z. We're not going to mess with that. Our x coordinate, if we want to express it in z, well, it's going to be x is equal to 1 plus z, right? So if I give you z, you can find x. If I tell you z is 1, then you know that x is 2. Okay, great. And then let's see if we can express y. And for this, we need to get this equation. We get 4x plus y, and then x, we can immediately substitute already. We can say x was 1 plus z plus y minus 6 times z, and we'll just keep z like that, is equal to 2. Moving everything to either side, we get y is equal to, here you get minus 4z plus 6z plus 2 or in other words, 2z minus 2. Giving us not a neat solution like this, but we can still express it, and we get, well, our x-coordinate is going to be 1 plus z, where I always have to give you z. Our y-coordinate is going to be 2z minus 2, and our z-coordinate is just going to be z, is just going to be itself. So these are going to be our many solutions because z is an element of the real numbers. So for any real number, you're going to find an answer. So you're going to find a line that goes like this. Let me pick the same color. So it's going to be like this. It's going to continue forever. Of course, I'm not telling you that it's over here. It's just some kind of visual representation of what's actually happening. It's just two planes intersecting with each other. Okay, so this for multivariable calculus for now, but try to remember that it's always, when you're dealing with a set of equations, there are three possibilities. First possibility, no solutions, no solution. One distinct solution, or many solutions. This is always going to be the case when you're dealing with systems of equations. Okay, so that for these linear systems of equations, let's dip our toes into non-linear system of equations at 7. And for 7, I'll start by making question A. And in general, these are much harder because, well, we actually have to be kind so that there is an easy way to solve these things. So if you get stumped, really take a step back and really try to see what the trick is that we put into it. Minus x squared minus 1. So here, addition method, which was so neatly you could do over here because everything was neatly linear, you could add these things up together. That's actually what you will see in linear algebra. If things are linear, they're really wonderful and you can do all kinds of things. Here, things are not linear anymore. So the addition method is not going to work anymore, but we can substitute still. So in this case, we could say, well, y is x squared. Great. We can rewrite that and we can say y is x squared, or y is equal to minus y minus 1, right? All I did was I filled this thing over in, this over here, I filled it in over here. Okay, we can rewrite this again a little bit. We find y is x squared still, and then we find 2y is equal to minus 1, or in other words, y is equal to minus 1 over 2. Okay, so we have a solution for y. Let's see if we can find a corresponding x solution. So we find minus 1 over 2 is equal to x squared, and y is equal to minus 1 over 2. And this, as you should know by now, squares within the real numbers, they can only give you positive numbers. So x squared is always greater or equal than 0. So that means within R, there is no solution. Okay, so that for A. Let's see what we can do with B now. So in this case, you always have to be careful to see whether your solutions are proper. So y is equal to x squared plus 1, and xy is equal to 1. Again, let's apply the substitution method. Y is equal to x squared plus 1. Here you get x times x squared plus 1 is equal to 1. Okay, this is great. This looks like a third-degree polynomial, so we can try and solve this. You cannot just read it off because unfortunately there's a 1 over here, not a 0, so we have to rewrite it a little bit. So we get y is equal to x squared plus 1, and over here you find x to the power of 3 plus x minus 1. So this is x. We did that. So x to the power of 3 plus x minus 1 is equal to 0. Okay, this is a third-degree polynomial. Let's try and find its roots. For this, we need to call in Horner's method. So we find 1 for x to the power of 3. For x squared, we find 0. For x, we find 1. And then for our constant, we find -1. Okay, a good possible candidate in this case could be 1. So drop 1 over here. I hope I didn't make a mistake, because I now see that I had a different solution. I see where my problem is. It's equal to 2, not equal to 1. So here this is 2, and this is 2 as well. So here for our constant we find -2 and not -1. And now this 1 is going to work. Okay, I was already worried. So 1 times 1 is going to give us 1. 1, 1 times 1, again 1. 1 plus 1, 2. 1 times 2, 2. And we end up with neatly dividing away one of our powers. So we can rewrite this a little bit already as follows. We can say, okay, y is equal to x squared plus 1. And here we find x minus 1 times x squared plus x plus 2. And all of that needs to be equal to 0. So this is going to give us 0 when x is 1. And then for this, let's see what our discriminant says. And our discriminant is going to be 1 squared minus 4 times 2 times 1, meaning that it's going to be smaller than 0. So it has no solution in the real plane. So our only solution for x is equal to 1. Okay, the only way to solve this is x is 1. Let's fill it in over there. So we get y is equal to 1 squared plus 1, and here x is 1, or in other words, y is equal to 1 squared plus 1. Okay, so that for question B. Then let's move to another exercise, and let's make question, which one did I write down? Let's make question F, because this is an interesting one as well. So y minus 2 squared is equal to minus x squared plus 6x minus 5. And then here 2x squared plus y minus 2 squared is equal to 1. Okay, where you have to be careful now is you do not want to start factorizing this. You don't want to start working this out, because this and this are just exactly the same things. So meaning you can just use this as a substitution. So what do I mean with that is you can just rewrite it as, here you have to give me a second because it's quite long to rewrite it. So minus x squared plus 6x minus 5. Well, that's going, if we fill that in, we find 2x squared plus all of this we found over here, because that's what minus y minus 2 squared is equal to. So minus x squared plus 6x minus 5 is equal to 1, or in other words, minus 6 is equal to 0. If we simplify this a little bit, this 2x squared minus x squared, we can rewrite it a little bit, and we find x squared is equal to x squared plus 6x minus 6 is equal to 0. Okay, great. For this, how would you solve this now? Again, just use your discriminant, and here you find 36 minus 4 times minus 6 times 1. So our discriminant of 40, giving us two possible solutions for x, x1, x2 is equal to plus minus the square root of 40 minus 6 over 2. Now, I'm going to leave it for here, but verify whether this, are they going to be good solutions for y. So are you going to be able to find y? I'll let you do that at home. I'll recommend 2 more exercises for home. So I recommend question E. That's a good one for you to make at home. And another one that's interesting to try at home would be question C. So try and make C and E at home and try to verify whether F is going to give you a solution or not. Okay, that's it for this week. I know it's quite a lot. Good luck with it. If you have questions, I hope to see you all soon, or whether it's physical or virtually. The professor will give you more information about that. See ya. Bye-bye.